the right to?
Yep.
Yeah. Okay. Thank you very much. Hello everyone, I'm Peter Ratford and I'm going to talk about how arch bridges work. There's a fine arch bridge, Sydney Harbour, not the sort of arch I'm going to talk about. This is an arch truss bridge with the deck hanging underneath. This is more the thing. Now this bridge inspired me, I have to say. It was a job back in the 1980s. I did the structural assessment of this bridge, great privilege, and it made me fall in love with masonry arches. And talking about engineering heroes, that was Sir Joseph Bazalgette who designed that. But we've been doing it a long time. There's ancient Rome, as mentioned. Yes, it's not a bridge, but hey, there's more arches in the Colosseum than you can shake a stick at. And a bit close to home, Landacre Bridge on Exmoor, one of over 1,000 bridges I used to look after in Somerset. Lovely bridge, lovely setting. But this is what it's really all about. It's about an old structures, and are they strong enough for modern traffic? So this sort of thing doesn't happen. I think in modern parlance you would say that that bridge isn't quite delivering its service standards. Okay, here's a diagram of what an arch looks like. Extros, intrados, voussoir, old Latin terms of course. So we can see where arches get their terminology. So here's one I prepared earlier and in the garage. Now it's a bit of a cheat, it's made of wood, so it's not like some other masonry arches, of course. Other features, it hasn't got any road construction or fill over the top, hasn't got spandrel walls on the side or parapets. Now all of these things make an arch an awful lot stiffer. So let's see what's going on. Now, if you imagine my hand is a bit of traffic, maybe someone walking up over the bridge, we get to here and the bridge gets really wobbly. And this is because force is extremely lazy. It likes to take the shortest route to the support. So when you're here, you can get a straight line down to the support here, but a straight line over there pops out of the arching over here. And I don't know whether you can see that. That side of the arch is popping up. And that makes the arch go into mechanism failure, which we've got on the screen there. And it's all a function of the shape of the arch, the slenderness and so on. But so it's about finding out how strong things are. But if we get up to the middle, it's a lot firmer. And the reason for that is, and it was designed to do this, is this arch can actually send a straight line down to the supports. And so, how strong is it? Now, I think I'll take these off because I don't want the IC associated with any disasters. And I should explain, I've actually specially put some weight on to give it a really severe test. And, oops, I think I'll just put this on as well, just to spread the load around a little bit. Ooh. What do you think? Now, what if I shift my weight around a bit? And that's why civil engineers need to understand how arches work.
Go sit down, Peter.
No, just so I can tidy up as well, sorry.
I think we should have randomly picked members of the engineering audience come and reassemble it.
Why not? Yes, please. Roll up, roll up.
That sounds like sort of ritual illumination that's on in order tonight. I have a few questions. Did you really make it in the garage? Is this what you get up to?
Yeah, I'm a regular sad kid. Yes.
That's fantastic. Let's go to our judges. Any people built or appreciated an arch in time? John Froud?
Peter, the examples you showed are all fairly ancient. Is there a future for arch bridges masonry?
Do you know there is? We've talked about sustainability. Masonry arches made of brick, made of stone, no concrete, very little cementitious material required, none really at all. There is a future, and it's about reinventing or reusing old technology. Very sustainable.
Simon, got a question with exactly the same. And are you persuaded by his answer?
Yes.
You wrote it in the time?
We did build one in Somerset about 20 years ago. Yeah. So it can be done.
Who would you have to how would you persuade a client that an arch is a good solution?
Do you know that there are some lost sort of skills, you know, massive arch construction and so on, but with modern technology, modern stone cutting, we can knock out these. I showed Putney Bridge earlier on. The stones in that, Cornish granite, bit of local interest there, massive stones cut by hand in a Cornish quarry, floated up the Channel, floated up the Thames, and they fitted first time. That was Victorian technology. We can do this with modern machine cutting, get the precision we need easily. Why wouldn't we do it?
I guess behind that question maybe is the sort of client vanity. When they come in to see you and they've got a great new bridge for your project and you know, your harbour or your road scheme or whatever it is, and here it is,
It's an arch.
it's old stone arches rather than driven across 100 years old. You're expecting something amazing new glass and steel in the sky.
I think a client who has sustainable credentials, they would go for it. Why wouldn't they? You know, I think when we're talking steel, and we talked about concrete earlier on, you know, there are significant sustainable issues around those materials. Why wouldn't we go back to the old techniques?
I love the way you're co-opting the earlier talk today. It's just a sort of appendix to your presentation. That's very nicely done. Ladies and gentlemen, Peter Ratford.
Thank you.
And now,